Routing Information Protocol, RIP, is another example of intra-AS routing protocol. It is less common. It is inflexible because for it, the metric is 1, meaning how many hops. We should say it's based on a distance vector, which means that I transfer the information to my neighbors and not advertise it to everyone at once, but slowly, while my neighbors also advertise their data, with the data they receive from their neighbors. I begin to understand what's going on in the network. I don't know the entire path, as I would have with Dijkstra or OSPF, but I do know if I want to get somewhere which neighbor I need to go to. And of course, when I advertise, I say which subnets I can reach. Let's look at the following example. Let's see, we have routers A, B, C, D, and subnets W, X, Y, Z. In this example, we look at the D's routing table. It knows about W, Y, Z, X subnets in hops of 2, 2, 7, 1. And the next router is either A or B, depending on our destination. Let's focus on subnet Z for now. If D wants to reach Z, it knows it needs to go to B and has 7 hops. Notice that I don't know the path. But suddenly A advertises. Remember, we advertise our tables after every X period of time or if there is a change, and it tells me, listen, if you want to pass through me in order to reach Z, I can do it in 4 hops. And I say, wait, 4 is better than my situation, because 4 plus 1 is 5, which is better than 7. Let's improve that. And this is how we update the table. But if I talk to my neighbors, I must realize if I know them. That's fine, that's at the beginning. But if they crashed, how can I tell if a link or a neighbor has crashed? What can I do? There is a setting that says that if I can't hear any update or advertisement, rather from a neighbor, for a certain period, let's say 180 seconds, then I understand that the link neighbor crashed and I need to update my table. And of course, advertise the updated distance vector and advertise it backward. There's also a problem because we're based on a distance vector that has a problem of count to infinity. That's in case there's an update. And then there's a ping pong between 2 routers because one wants to go to the other, but the other doesn't know about it. They use poison reverse to prevent it. RIP itself works on the application layer, meaning it works over UDP, over IP, and link and physical. Although, if we think about it, as far as we're concerned, we're on the network level. But it's important to understand here that we work in RIP, which is unlike what the OSPF has done, working over the IP itself. That's it. To summarize, we've seen 2 intra-AS examples, OSPF and RIP. One is link state-based, the other is distance vector-based. I believe you will mostly encounter OSPF.